Welcome to video 5.2 Bravo, proof of parallel lines. So here's going to be an example implementing one of those theorems before. So here's the problem. Given this figure with AB and BC bisecting each other at point E, prove that AD is parallel to CB. Okay, so I'm looking for one of those 6 ways to prove those lines parallel. For the most part, they involve angles, okay? And if I want to get angles, oftentimes I want to get triangles. And if I want to get triangles, that's going to be by SSS, SAS, ASA, HLR. So that's kind of the flow path for where we're going. All right, so let me start by marking up the diagram. So AB and BC bisect each other. So that means that this chunk is congruent to that chunk, and a different symbol for there. They're not all 4 congruent, just this and this and that and that. Okay, and I'm going to prove that this is parallel to that. Okay, well, one thing that helps my brain is to extend the lines and think of a transversal. So what I'll do is I'll extend this, and I'll extend this, and I can think of either one as being a transversal. I'll just call this line being a transversal. All right, so then I could be thinking alternate interior, alternate exterior, so let's come up with a game plan. If I got these triangles congruent, then I could get the corresponding parts congruent. This angle with this angle, and then I would have alternate interior angles being congruent. Game over, the line's parallel. So now it ultimately boils down to getting the triangles congruent. One more thing I can mark up. Obviously those vertical angles are congruent. Boom, triangles by SAS. I'm going to write down SAS just to serve as a reminder to me to get the sides, get the angles, get the sides again. Okay, so let's do the proof now. So I'm going to go in SAS order. I'll start with this. AB and BC bisect each other at point E. That was given. From that, I could say CE is congruent to DE. And I could say if bisect, then 2 congruent segments. If bisect, then 2 congruent segments, and I've got a side involved there. Okay, I'll go for my angles. Don't just use letter E, that's confusing. You're going to use 3 letters. Angle CEB is congruent to angle DEA if vertical angles then congruent. Okay, got my angle. Then from the bisecting, I've got the other ones. Again, that stems from this. So just a little jump in logic. It's okay to draw arrows. So I'll go BE is congruent to AE. Again, if bisect, then 2 congruent segments. Then I can get the triangles. Triangle, whatever I'll call it, CEB. CEB. Now once I call a triangle CEB, I gotta be careful with my ordering. So C was over there, that's when it corresponds to DEA. And I usually do my angles in the same order just as a helpful memory device. And that would be by SAS. Then getting the angles, I could just use 1 letter there. So angle C would be congruent to angle D by CPCTC. And then we'll just put a dot there and a dot there. And that helps me visualize I'm on alternating sides, the transversal, and I'm on the interior of the two lines. So I gotta say if alternate interior angles congruent, then the lines, oops, that was the reason, I'm sorry. If alternate interior angles congruent, then the lines are parallel, and I was trying to get this right here. AD is parallel to CB. So there you have it, how to do a basic proof of getting lines proven parallel.